Okay, in this video, I'm just going to show you how to answer a typical geometric series question. The first thing that I wanna point out is the fact that when you attempt to answer the questions about a geometric series question, arithmetic series question, or quadratic pattern question, the first thing that you have to do is use the information that have been given, analyze it to make things easier for you to answer the questions that follows that question. You know what I'm saying? So what you have to do first is use the information that have been given and then analyze it. That is going to help you to find it easier for you to answer the questions. So in this typical example, we have been provided with the geometric series, and then it has the following terms. It has 45 plus 40.5 plus 36.45 and so on, right? So when I've been provided with an information such as this one, what you have to do first is analyze it, like I said, right? So analyzing this question or this information that I've been given, I've noticed that, or I can notice that because there's a geometric series, the nth term formula is Tn is equal to A multiplied by R to the power n minus 1. This is the nth term formula, right? So in this formula, I'm gonna need the value of A, right? And I'm also gonna need the value of R. So I have to find those values in the information that I've been given, right? So A is always the first term. So in this example, we do have the first term, which is 45. So I'm just going to write here, A is equal to 45. However, I do not know what the value of R is. So to find the value of R, in a geometric series question, R is equal to T2 divided by T1, right? Which is also equal to T3 divided by T2. So what is T2? T2 is 40.5 divided by 45. That means R is, and then we press our calculator. So pressing our calculator, we get 40.5 divided by 45. How much is that? That is 9 over 10, right? So that means that R is 9 over 10. But I've said that R is equal to T2 over T1, which is also equal to T3 divided by T2, right? So I just want to show you, if a question asks you to prove that T2 divided by T1 is indeed equal to T3 divided by 2, if a question requires you to prove that this is equal to this, what you just have to do here is substitute and check. If they're not equal, that means this is not a geometric series. But if they are equal, that confirms that this is a geometric series. I know that this is not a question that I've been asked, but then I'm saying in the future, if they require you to prove that this is a geometric series, or to prove that T2 over T1 is equal to T3 over T2, this is how you're going to do it. Because we have found out that T2 over T1 is equal to 9 over 10, we have to also prove that T3 over T2 is equal to 9 over 10 as well. So we're just going to substitute here. What is T3? T3 is 36.45, and then T2 is 40.5, right? So what is the value of that? If it is 9 over 10, that means this is indeed a geometric series. But if it is not equal to 9 over 10, that means this is not a geometric series. We're dealing with a different series, which we have to find out what it is, right? So let us just press a calculator here. We have 36.45. I don't know if you can see that. Okay, yeah. 36.45 divided by 40.5. Let us check how much that is. Okay, well, that is 10 over 10. That means that this is indeed a geometric series, right? So if you were required to prove that this is a geometric series, this is how you was going to do it. But in this case, we're not asked to prove. However, this was just for the convenience of it. So that means that indeed T3 over T2 is 9 over 10 as well. So this just has confirmed the value of R. So that means A is 45 and R is 9 over 10, right? Therefore, or this implies that Tn is equal to, now that we have the values of A and R, that means Tn is equal to 45 multiplied by 9 over 10 to the power n minus 1. That means the Tn, or the nth term, is equal to 45 multiplied by 9 over 10 to the power n minus 1, right? We have not yet answered the questions. So this is what you should do first before you attempt any question. Now let us go to the questions. This is how we analyze the information that we've been given. Okay, now the first question says, determine the 12th term corrected to 2 decimal places. Okay, now they want the 12th term, they want T12. So to calculate T12, fortunately enough, we have already determined the nth term, and we said that Tn is equal to 45 multiplied by 9 over 10 to the power n minus 1, right? So to calculate T12, we're just going to be like T12, where we see n, we put 12. So 45 multiplied by 9 over 10 to the power 12 minus 1. So where we see n, we put 12. So that means T12 is equal to, and then we press a calculator, right? And then find out what T12 is. So pressing our calculator, we get 45 multiplied by 9 over 10 to the power 12 minus 1. They said to correct it to 2 decimal places, right? So that's 14.12. That's 14.12, right? So the answer is 14.12. So that's T12. So another skill that you should master in an exam is the fact that if you're asked to correct to whatever amount of decimal places, you should know how to do that on a calculator, right? So that you may not have a lot of work converting manually, right? So to set up your calculator to help you always convert your answers to a certain amount of decimal places, in this case 2, you're going to press shift. This works for a whole lot of different calculators. It works for daily, it also works for Casio. I'm not sure about Sharp, but I know about daily and Casio. Hopefully other calculators as well, other scientific calculators as well works the same way. So you're going to press shift and then go to mode. So that's a setup, right? So you're going to have a menu of 8 options. So you're going to press 6, number 6, and then depending on how many decimal places the question has required you to convert your answer to, you're just gonna in this case it is 2, right? So we're just gonna press that number. If it is 3 decimal places, you're gonna press 3. If it is 2, 2. If it is 5, 5, and so on. So in this case it is 2 decimal places, so I'm gonna press 2. So the answer is going to be corrected to 2 decimal places automatically. You get that? Okay. If you didn't understand the whole process, please pause the video or at least make it slower or rewatch it again, because I'm not going to repeat it. Yes. So the next question, question 2, says, give a reason why this series converges. Okay, so if you're given a geometric series, or when you're dealing with a geometric series question, every time they ask you to prove that a series converges, or they ask you for a reason why the series converges, you're always gonna state the same reason. The reason is that R value is greater than -1 and less than 1. So this is the condition where a geometric series converges. Geometric series converges. So geometric series converges for R is greater than -1 and less than 1, or R is between -1 and 1. This is the only condition for which a geometric series converges. So any time they ask you for a reason why a geometric series converges, you're gonna just write that. You don't even need to write anything else. You just write this. It's a reason on its own. Okay. So the next question, question 3, says calculate the sum to infinity of the series. So now they're looking for the sum to infinity, right? So I'm just gonna slide the paper to the left to have more space. So now they're looking for the sum to infinity, right? So sum to infinity, this is question 2 and this is question 3. So sum to infinity is equal to, if you need a formula for that, if you don't know it by heart, you can just go to the back of the paper. There's a formula sheet that provides you all the formulas for everything that you need to calculate. So for sum to infinity, the formula is sum to infinity is equal to A divided by 1 minus R. So now we need the value of A and the value of R. We're just going to substitute them to get that value of the sum to infinity. So A is 45, right? And then 1 minus R. What is R? We have found out that R is 9 over 10. So this implies that the sum to infinity is equal to, then we just press a calculator, right? So pressing our calculator, we get the sum to infinity to be 45 divided by 1 minus 9 over 10, right? What is that equal to? It is equal to 450. So sum to infinity is equal to 450. Okay, moving on to the next question, which is the last one in this case, question 4. So question 4 says, what is the smallest value of n for which the sum to infinity minus the sum to number of terms is less than 1? So they're asking for this. They're asking for the smallest n for which this is true. Sum to infinity minus the sum to number of terms is less than 1. Okay, so this is not a straightforward question because we do not have this. We haven't even dealt with it. We haven't dealt with sum to the number of terms. We only have dealt with the sum to infinity. So the only thing that we know here is sum to infinity. And then what is sum to infinity? Sum to infinity is equal to 450, right? We don't know what sum to the number of terms is because we don't even know how many terms there are in the series, right? So because this series is geometric and it converges, that means it is infinite. So it goes on forever. That means we don't have a last time. All right. So if we don't have the last time, we don't know how many terms there are. However, we do know that there's a formula for calculating the number of terms, the sum to the number of terms. So that formula is the sum to the number of terms is equal to a multiplied by 1 minus r to power n, all divided by 1 minus r. So this is the formula for calculate the sum to the number of terms, a specific number of terms, right? And we also have a formula for the sum to infinity, which we have stated here. It is a over 1 minus r, right? So they're looking for the difference between the two. So they're saying that what is the smallest value of n for which the difference between these two is less than 1, all right? So now what I have noticed from these two formulas is the fact that they have the same denominator. We have 1 minus r here and here as well. So the fact that there's a common denominator, there's a rule. I don't know if you're going to be familiar with this, but there's a rule that says if we have the same denominator, 1 over 3, for instance, minus 3, no, minus, I want to say 2, yes, minus 2 over 3. So if we had something like this, 1 over 3 minus 2 over 3, because we have the same denominators, we can just subtract the numerators, meaning 1 minus 2 divided by 3. So we're going to use the same principle in this case here. We're going to utilize this same principle to calculate the difference between the sum to infinity and the sum to the number of terms. Okay, so for that, I'm going to go to the next page because I don't have enough space, as you can see. Okay, now I'm on the next page and I'm going to continue with my calculation. So they're saying that what is the smallest value of n for which the sum to infinity minus the sum to the number of terms is less than 1. So now I'm going to substitute my formulas. So sum to infinity is a over 1 minus r minus the sum to the number of terms is a multiplied by 1 minus r to the power n over 1 minus r. This whole thing should be less than 1, right? So because we have the same denominator, we can just subtract the numerators because we have a minus sign between the two fractions, right? So the first numerator is a minus, and then the second numerator is a multiplied by 1 minus r to the power n, and then a common denominator is 1 minus r. This whole thing less than 1. Okay, now I can notice that in the first term and the second term both have a, right? So I'm going to take a as a common factor. I'm going to take it out as a common factor. And then to get a, we multiply a by 1, right? And to get a multiply 1 minus r to the power n, we multiply a by whatever that was in the bracket, which is 1 minus r to the power n. This whole thing divided by 1 minus r. This whole thing less than 1, right? At this point, we can just substitute the values of a and r and leave n and solve for it. However, I don't want to get there first. I want to make sure that I simplify things so that things become clear and simple for you to see. And then later, when I'm done simplifying, I can solve for n, right? What I mean by that is I'm gonna leave a and then solve everything that is inside the bracket. So a multiplied by 1 minus 1, so negative multiplied by 1 is -1, and then negative multiplied by negative is positive, and then we have r to power n, so this is what it was in the bracket. We have try to solve it, and then we have 1 minus r less than 1. Okay, what is inside the bracket is a 1 minus 1 is 0, so we only left with r to power n divided by 1 minus r is less than 1. Now at this point we can substitute the value of a and the value of r. So we know that a was 45, and then what is r? R was 9 over 10, and then to power n divided by 1 minus 9 over 10. This whole thing less than 1, right? And then I'm gonna try to calculate what this is. What is 45 divided by 1 minus 9 over 10? I think I have calculated this before because it really seems familiar. So I think I have calculated before. I'm just going to check what the value of 45 divided by 1 minus 9 over 10 is. Oh, let me just go back to the previous paper. Remember when we were calculating the sum to infinity? I'm here. When we were calculating the sum to infinity, we had something like 45 divided by 1 minus 9 over 10, right? We had this, right? So 45 divided by 1 minus 9 over 10, we got it to be 450, right? So where I see 45 divided by 1 minus 9 over 10, I can just put 450, right? So because here we have 45 divided by 1 minus 9 over 10, I can just be like, that's 45, I mean that's 450, and then multiplied by 9 over 10 to the power n less than 1. So this is where we are at, right? So I'm gonna need to keep on solving this equation until I get n, right? Simplify until I get n. So from here is just algebra, right? So I have, just wanna make sure that you see this. Okay, I have 450 multiplied by 9 over 10 to the power n is less than 1, right? So dividing both sides by 450, I get 9 over 10 to the power n is less than 1 over 450. Then from here I can introduce what? Logarithms, right? So introducing logarithms, I'm gonna be like the n. Okay, well, the first thing that I have to say is the fact that the base of the whatever that we're looking for is n, right? That's the exponent. So the fact that the base of what we are looking for is less than 1, so the base is less than 1. So the base is between 0 and 1. It is greater than 0, however it is less than 1. So if this is the case, that means that when we include the logarithm rule or law, the sign, I mean the direction of the inequality sign is going to change. Because now it is less than, it's going to change to being bigger than. What I mean is n as an exponent is going to be greater than the log of the base, and the base is 9 over 10 multiplied by 1 over 450. So the first direction that this inequality sign was taken was less than. Now it has changed direction to being bigger than. It was less than, now it is bigger than. Why? Because the base of the exponent that we are looking for is greater than 0 but less than 1. I hope that is clear. Now we just press the calculator. This implies that n is greater than, and then we just press our calculator. So pressing our calculator, we get the log of 9 over 10 multiplied by 1 over 450, right? So what is the answer to that? That is 57.98, right? So we have the answer is 57.98. So that means that n is greater than 57.98. So they're looking for the smallest number or the smallest value of n for which this whole thing was true, right? So because n is greater than 57.98, what is the next whole number or natural number that comes after 57.98? Or what is the closest one that is greater than 57.98? It is 58, right? So that means the smallest number or the smallest value of n for which this whole thing is true is equal to 58. So this is the value that we were required to calculate. So n is equal to 58. So this is how we solve this problem. Okay, thank you very much for watching this video. I hope that I made a difference in some knowledge that we had about geometric series mathematics. I hope that you did enjoy the video. Don't forget to leave a comment, a like, or subscribe to my channel. And I hope you have a great day.